Um, my name is Shaltiel Shmidman. I work at Dicta, and in this talk, I'm going to delve into the process that went into evaluating Dicta LM 2.0, which is a language model we released in collaboration with Mafat, Intel, and the IELT, which is the LLM dedicated for Hebrew processing. So a little bit about Dicta. Dicta, the company I work for, is a nonprofit organization dedicated to bringing the cutting edge technologies of machine learning and natural language processing and applying them to Hebrew, which is highly underrepresented in the general world. So I'd like to start with a little bit about the model, Dicta LM 2.0, a quick introduction for those of you who aren't familiar with the model. Dicta LM was a collaboration, as I said, with Mafat, Intel, and the IELT, which was a project to develop and train a language model, an open source language model that is high performing on Hebrew tasks specifically. This kind of model was very lacking in the open source world, and this was our project to release it. So the model was based on Mistral 7B. It was a state-of-the-art model back when we started training the model, and it was an open source, open weights model that we had a very freeing license. We improved the tokenizer by extending it, adding more tokens, improving the compression rate by a factor of 2.2, meaning that each word requires less than half the amount of tokens in our model versus in the base Mistral model that we use. Then we continued and trained the model on 190 billion tokens, where 95 billion tokens are in English and 95 billion tokens were on non-synthetic Hebrew, meaning naturally occurring Hebrew text. That is, after we ran it through a thorough cleaning process and also did a very thorough deduplication in order to make sure that all the data we had was very high quality. The model is available on HuggingFace for anyone who wishes to use it. Both the base model and the dedicated chat model are available for anyone who wants to take it, use it commercially or for academic purposes freely. In addition to the models being available in HuggingFace, we also have a demo of the chat model available on the HuggingFace Spaces for anyone who wants to use and test it out to see if the model works for their use cases. This is specifically the chat model. There's a QR code on the screen for anyone who wishes to access it, a direct link to it. And in addition, we also put up a translation demo, which is based on the Dicta LM base model, not on the chat model. And we provide this also as an online tool for anyone who wishes to use. The link is on the screen. And here's an example of a slightly complex sentence in Hebrew. And the translation system really was able to capture the meaning of the sentence and translate it properly. So if anyone wants to use it, it is available on the link here. So this was a quick intro to the model, and now we're going to delve into the main part of the talk, which is the evaluation. When training a model, evaluating the LLM is a crucial part, and not only in LLMs, but when training any machine learning model, evaluating it is one of the most important parts of training a model. I saw a great quote the other day, which goes, "Evaluating LLMs is the cornerstone of building trustworthy, fair, and groundbreaking AI for all." Meaning, in order to produce a model that people can use and people know that it'll work for their needs, we have to evaluate it in order to build upon it and to know whether our model is actually better or worse or how it compares to every other model. If we were to release our model and not provide any kind of evaluation for it, we would look kind of foolish both to ourselves and to everyone else for not being able to provide any kind of metric for whether our model actually solved or actually improved upon existing models. Therefore, as part of training Dicta LM 2.0, we took it upon ourselves to build a wide evaluation system that covers various use cases and capabilities of the language model, and making sure that our model actually performs as we expect it to. So a quick intro about what goes into building an evaluation task. So the first step is defining the task. What is it that we want to determine to determine whether the LLM is capable of doing. We want to first define how what is the measure that we are determining, so that we know that if the model gets a higher score on this task than a different model, then we know to use this model. The second step is constructing the test set, where we build the list of prompts that we want to use, and also defining the specific format of the prompt so that the model produces results as we expect them to, which I will delve into further on. And finally, it's to choose which evaluation method we're going to use. Now, there are three main evaluation methods that exist for evaluating LLMs. The first is automatic evaluation, where given a result from the model, we run some sort of automatic measure which is run on the outputs and can produce a numeric result for us. So if we were to produce a set of outputs from the model for various questions, we would have some automatic way to determine how well the model succeeded. The second is human evaluation, where we produce results from the model and have humans review the results and score them themselves. And thirdly is AI evaluation, which is an alternative option to human evaluation, except it's more scalable, and we use a powerful AI model to evaluate the results instead of having a human evaluate it. So let's start with the automatic evaluation. So when training a large language model, you don't start with a chat model. You start with a base model. But now, what is a base model? A base model is a generative large language model that doesn't know any kind of patterns that you want it to do. Rather, you give it a prompt, and it just knows how to continue forwards. If you start and saying, hello, my name is Angela, so it'll continue saying, and I do this and this. It knows how to complete sentences, but it doesn't know how to follow instructions. So this begs the question of, how do you even test these base models? So a naive approach would be, given a sentence, for example, אני מאוד שמח לדבר בוובינר הזה. I'm very happy to speak at this webinar. I then ask the model directly, is this sentence positive? Now, this would be, ideally we'd want the model to respond either yes or no. But instead, the model generates more questions of the sort. It says, is it negative? Is it neutral? Is it positive and negative? Which is a very valid continuation to the prompt, but it doesn't answer our question. So then I tried to be, you can try to be a little more creative and say, okay, we're just going to prompt it to complete this sentence is, and have it decide whether it's positive or negative. But if we would run this, the model would just complete it and say, okay, it is the opening sentence of every webinar I deliver, which is also a very good continuation to the sentence, except it's just not the results we want. So in 2021, OpenAI put out an article which is called Language Models Are Few-Shot Learners, where they show that these large language models are able to learn patterns. And if you gave it a few examples of what the input and output is, meaning given a specific kind of input, what the output is supposed to look like, then the model learns the pattern and will follow that pattern when predicting the next output. So using that, we can give the model two examples of positive sentences and two examples of negative sentences. So in the first one, the sun is shining, it's a bright day, and we give it a positive. And here we essentially define a kind of pattern. We give it a sentence, and then we say the word sentence, and then give it the sentence, and write the word answer, then get the answer. So we constructed this prompt, which gives it 4 examples, 2 of each category, and then we provide it with the question at hand, which is, I'm very happy to speak at this webinar, and then we continue the pattern till the word answer. But here is where we tell the model, okay, now predict from here. And the model learns to look at the previous examples, it learns the pattern, and therefore knows to say, well, this is very clearly a positive sentence. And now, once we discuss sentiment, we can delve into the first task we used, which is sentiment analysis. The sentiment analysis task is the task of given an example sentence to classify it as either positive, negative, or neutral. So this is a fantastic task for evaluating a language model. But one might ask, why is it a hard sentence? Why is it a hard task? Just, easily look at, how many positive words there are. For example, if you look for the words like good, happy, then you know it's a positive sentence. If you look for negative words like bad, sad, then you know it's a neutral, then you know it's a negative sentence. So where does the complexity come in? And so here's an example sentence of where it's not so obvious. It starts by saying it's a good movie, but for brainless people. That's very clearly a sarcastic sentence that is very negative about the movie, but without understanding the intricacies of the language and the subtleties that people use in order to express emotion, a model will not be able to understand and classify sentences as positive, negative, or neutral. Therefore, this task is actually a very good task for evaluating how well the model understands the language. So once we defined what our task is and we understood it, so the next step, as we know, is to construct a test set. So for our test set, we use the Hebrew sentiment dataset, which was released by the National Program in Israel for Natural Language Processing for Hebrew and Arabic, which is a dataset that was released a few months ago. We then had a human annotator go through and pick out 3,000 examples that weren't extremely ambiguous, that were relatively clear, that had a relatively clear analysis that couldn't go both ways. And that gave us 1,000 examples of each category. And for our measure, because the model is going to produce one of the three classes, because that's how we constructed the prompt, we can simply compute a simple accuracy measure, which is how many times does the model get it correctly. So our actual prompt looks like this, where we gave it a sentence and whether it's positive, negative, or neutral. Now, in order to really help the model understand the task, we gave it 9 examples, 3 of each task, and we mixed the examples around in order to make sure that the model learned to understand the pattern between the word, the sentence, and the answer, and not try to somehow extrapolate a different pattern of the order in which the sentences were placed. So then once we give it the 9 examples, we provide it with a simple sentence at the end and have it produce the answer. So that was the first task we evaluated the model on. The second task is question answering, where given a context, a paragraph, we want to answer a question from the context. So, for example, if we had a paragraph here that talked about last Tuesday when Michael wore a white shirt before he left the house, etc., etc., we want to know what color was Michael's shirt. Now, this is a task that involves understanding a question and pulling the answer out of the text. Now, once again here, one might ask, why is this such a hard task? You know, you can look for the pattern and say, oh, look, it says the shirt, it says the word shirt, figure out where it fits in the paragraph and pull it out. But if you'll notice that it's not so clear. For example, the word color, it's misaligned here, but the word color appears in the question, but does not appear in the paragraph itself. So the model has to actually understand that the word color actually refers to the word to the color of the shirt, which is white. The second thing you'll notice is that the word white appears in Hebrew as levana in the text, but the answer is the more correct way to specify the answer is to say lavan, because here it is in the context of the shirt, and therefore it's a negative, but the answer will give us a different conjugation. So all these plus more exhibit why this task is actually not so trivial and requires the model to understand the semantics of the sentence and to pull the answer out of the context. So once we defined our task, once again we move on to the test set. Now we use the HEC dataset, which is a dataset released a few months ago, and we took the test subset of the dataset, which contains just under 1,500 examples. And in order to measure the correct answer, we use the TLNLS score, which was introduced in the HEC article. Now, the TLNLS score is a score that is used to approximate the accuracy of a answer, taking into account the way Hebrew is built and the different conjugation, and estimates it using a mixture of Levenshtein distance and the F1 score. So once we determined our score and our data set, so this is what our prompt looks like. We give it a paragraph with context, and then we give it 3 examples of questions and answers about this paragraph. And finally, we give it the question at hand. And then we prompt it in the same pattern and have the model predict what is the correct answer. So this was the question and answering task. The next task we moved on to was the Winograd schema. Now, the Winograd schema is a complex task that tests whether the model is able to understand sentences that have an ambiguous syntactic structure and be able to disambiguate which object is being referred to. So to understand, I'll give this example. אייל סימן לברמן והצביע על הארנק שלו. של מי הארנק? Now, as anyone who has basic world knowledge knows that if Ayal is pointing to is signaling to the barman, it's clear that Ayal is a customer at a restaurant or at a bar, and he's pointing at his wallet, meaning he wants to pay. So for us, it's a very simple explanation, but the model has to understand that we're also talking about barman, that it's a barman and it's not the name of a person. And if the model would and if the sentence was slightly different, if instead of barman we had the client, then the wallet would be for the client. So this involves a very understanding of the world knowledge and the way Hebrew works in order to properly evaluate these sentences. So we moved on to constructing the test set. We took the translation of the Winograd Schema Challenge to Hebrew, which is a translation by Dr. Vered Schwartz, a PhD graduate from Bar-Ilan University and is currently an associate professor in a university in outside of Israel. And it contains 278 examples of these ambiguous sentences. And for our measure, we narrowed it down to a binary classification, where the model has to choose one of two answers in order to produce the answer. So that way we can evaluate using a simple accuracy measure, how many times did it get it right. So the way we did it is by providing the model with a question, the possible answers, and the correct answer. And that way, when we present it with the question at hand, it knows to pull the correct answer from one of the two options. The final measure we used, which is the Hebrew to English translation. The Hebrew to English translation is a task that I think everyone here already knows is a very difficult task and definitely not trivial. So I don't need to go into why it is hard. And so we can skip that task. We can skip that stage of defining the task and move straight to the test set. So we use the New Labs TED Talks dataset, which is a dataset which took a series of TED Talks that have subtitles and aligned them between various languages. So this provided us with a set of sentences that in both English and Hebrew that were aligned. So we took 1,000 random sentences from the corpus that we ensured multiple times did not appear anywhere in our training corpus to avoid any contamination. For our measure, we used the BLUE score, which is a standard metric for computing accuracy on machine translation. It checks how many n-grams overlap between the gold sentence, meaning the translation we know, and the machine translated sentence, and checks how much overlap and uses that to construct the score. And our prompt looks similar to the prompts in the previous examples, where we give it a sentence in English, a sentence in Hebrew, and at the end we give it a sentence in English, have it predict the Hebrew, and we do the same thing in reverse, where we give it the Hebrew then the English, and then at the end give it a sentence in Hebrew and have it produce the English sentence. So we took all these tests and compiled them into the first Open LLM Hebrew Leaderboard. So first, as you can see, that our model produced better performance on most tasks than the existing models, and on average gave us a boost and produced a strong baseline for evaluating Hebrew for large language models performance on Hebrew. Now, I'd like to note that this leaderboard is available to the public. There is a QR code for anyone who wishes to access this leaderboard. And we'd like to note that this leaderboard wasn't just constructed for us to evaluate our model. Rather, it's a call for action to the community to develop and train large language models in Hebrew and not have to worry about the evaluation, because we already did the work for you. And now there will be a standard baseline benchmarks for evaluating these models. and we strongly encourage everyone in the community to train models and submit them to the leaderboard to be automatically evaluated. So now that we discussed the automatic evaluation, we move on to the second evaluation method, which is human evaluation. This is also known as human as a judge, where we provide the model with results from the model, and the human judges how good they are. So for our task, we use translation preference, where we provide a human with two sets of translations and have him choose which one is better. Now, so for our situation, we took 1,000 sentences in English and we translated them to Hebrew. Then we translated them to Hebrew both using our Dicta LM 2.0 model and Google Translate. And then we anonymize the translation by putting them in two unmarked columns in a spreadsheet and gave it to a human to choose for each translation which he thinks is which translation he prefers. Now, the importance of anonymizing is so that the human doesn't have any bias towards which translation engine he prefers, but rather can choose without any bias which translation he prefers. So here are the results for this task, and as can be seen, the Dicta LM 2.0 model is preferred a significant amount of the time. Over 74% of the time, the user preferred the translation of Dicta LM over the translation of Google Translate. Now this is huge because this also puts a tool in the hands of everyone in the public to translate text between Hebrew and English freely and without any cost and very high quality translations. So the third evaluation method is the AI evaluation, which is also known as model as a judge. Human evaluation is very good, but it's also very expensive and hard to scale because humans only work so fast and it's very difficult to hire massive amounts of humans to evaluate tasks, whereas AI models are very easy to scale and you can easily run lots of evaluations. So for this task, for our AI evaluation, we took the summarization task, which is a generative task which tests something on the model that we didn't test before, which is its ability to generate text and not just the way it understands and its reasoning. So for this task, we took 75 documents where we had human summaries for these documents, and then we generated summaries for these documents using various models. And then we had GPT-4 evaluate how well each summary is, and that way we can compare how well our summaries are in comparison to other models and to the human summaries. So the first step is the generation. So in order to generate the summaries, we ran this on the chat model or an instruct following model because defining this as a few-shot example is difficult due to the context length. So we used our chat model, the Dicta LM 2.0 instruct, and this was our generation prompt. We provided it with the document, and then we provided it with a paragraph describing the exact summary we want in some detail. This was the same prompt we used for all generations of the summaries in order to have a fair comparison. The second stage is now evaluating. So in order to figure out how you evaluate a summary, we followed the OpenAI cookbook recipe that they put out in 2023, which evaluates the model on 4 different tasks, on 4 different measures. The relevance, meaning how well does the summary capture the relevant facts from the document. The second part is coherence. How well do the sentences in the paragraph, how do they flow together? How coherent is the paragraph as a whole? Consistency. How accurate are the facts in the summary in comparison to the document? We want to make sure that they're all very consistent. And finally, fluency, which is the nitty-gritty of the language, which is the grammar, the conjugations, the language in general, how well the Hebrew sounds. Now, the exact prompt we use can be seen on the OpenAI recipe. We slightly modified it for our use case, but we pretty much took it verbatim. So we ran each of the summaries through, we generated the summaries and then ran it through GPT-4 as our evaluator. And as you can see here, the results. as can be seen, Claude 3 and GPT-4 produce results that are very similar to human results, which is to be expected. And we're not aspiring to compete with them, since we don't have the resources that Anthropic and OpenAI do. But we outperform Gemma and GPT 3.5, which are very strong based instruct models, and we produce here a model that, although it's not up to par, it's not state of the art, but we actually we produce a very strong alternative for anyone who is interested in, who can't use the closed source models. We provide a very strong alternative for anyone who wishes to use this as a base model or as an instruct model for their tasks, whatever it may be. So to wrap up this whole talk, evaluating large language models is a very difficult task that is not defined well and requires a lot of work, but it is crucial in order to properly be able to train models and to see that the models are training properly and not regressing, in order to compare various models on different languages, on different tasks. We discussed 3 different methods for which are the human evaluation, AI evaluation, automatic evaluation, which each one is suitable for a different type of tasks depending on whether there is an automatic measure to use, whether you want to whether it's scalable to use for humans. All these different conditions that help choose which method you use. And finally, we introduced the Open LLM Leaderboard, which again, we'd like to note that we'd like to encourage that this leaderboard is for the public, and we encourage the community engagement, and we encourage everyone who has access to a GPU to train a model, train it on your data, train it in any method, any trick you think might improve the model, and see how it performs on the leaderboard. And thank you.